Hi dear friends and viewers, welcome back to our channel Vinay Kumar Basics of Physics. Dear students, as part of preparation of JEE, EAMCET and NEET, we are discussing the units and measurement chapter. In that unit we are going to discuss about the how the significant figures can be used in arithmetic operations like subtraction, addition, multiplication and division. That is the topic here we have to discuss in this video. Watch the video till the end, it must be useful to you. Clear? So how the significant figures can be used in addition and subtraction. When in a given problem we have so many numbers. In that numbers we have to select the particular number which has least decimal places. Clear? That least decimal places should be, we have to note it. And after doing the arithmetic operation like addition, you have to round off the result should be to the least decimal value what we noticed. Clear? So we will discuss one example, then automatically you can understand this one. Let's go further. Here the result of an addition or subtraction in the number having different precisions to be reported to the same number of decimal places, as present in the number having the least decimal places. Clear? The value of result going to be round off up to the least decimal places of a given number or given numbers. Okay, look here now. Some examples are there. Then after completion of example calculation, you may get very clearly. 1.2 plus 3.45, 6.789. So we have to add them like this. 6.789 is the one number and 3.45 is the another number and 1.2 is the another number. So we have to add them and we have to round off the final result. First you have to observe this number 6.789. After decimal point, how many numbers are there? 1, 2, 3. So how many decimal places? 3. Here 3.45. Here how many there? 2. Here 1.2. How many here? 1. So now here you have to select the least decimal place value, that is what? 1, and that should be taken as n is equals to 1. After adding all these numbers, the result is going to be rounded up to the same decimal place value 1. Clear? So we have to add them. 9, 13, 2 plus 1 3, 7 plus 7 14, 1, 2, 5, 6, 11.439. 11.439. How many decimal places here? 3 are there. Clear? In this answer we have 3 decimal places and that should be going to be a round off up to the n is equals to 1. That means the final result also going to be rounded off to the 1 decimal place. Clear? Now 11.439. Here 9 is the digit that should be greater than the 9 is greater than the 5. Then the preceding number should be going to be added by 1. Then what you get? 11.44. Clear? 9 is greater than 5. Then the preceding number is raised by 1. Clear? That's what you can write. 11.44. Again this 4 is less than 5. And now it is, we can omit that one. There is no changes to the preceding number 4. Then what you get? 11.4. So initially what you got? 11.439 is there. After rounding of the numbers, what you get? 11.4. That's why here the value is going to be right here 11.4. See the next example. We have same question is there. 13.33, 3.11, 0.313. We have to find out the value and that should be round up to the required decimal places. First thing here 33.3 and 3.11 and 0.313. Clear? First you have to identify the number of decimal places. After decimal point, here only one number is there, that's why here decimal places are 1, here 2, here 3. That's why you have to select the n value is how much? 1. That's why the final answer what we are going to gain, that is also rounded up to the n is equals to 1 decimal places. So and now here 3, 2, 7, 6 s 36.723, 36.723. This is the result, and you have to identify now how many decimal places? 3. Now it is going to be reported to the decimal places 1. Clear? So here the last insignificant digit is what? 3, that is less than 5, that's why it is omitted, 36.72. And again 2 also less than 5, that is also omitted. We have now 36.7, that's why here the answer is what? 36.7. In the same manner we have to identify this one. Here 3.1421, how many decimal places? Here 4, 1 2 3 4. Here 3 decimal places, here 2 decimal places. That's why the answer is going to be rounded up to the 2 decimal places. 2 decimal places. Clear? Look here now. 3.1421, 0.241 and 0.09. So here now 1, 2 plus 1 3, 4 plus 4 8, 8 plus 9 17, and is 4 and it is 3. 3.4731, 3.4731. That's why here 3.4731, how many decimal places here? 4 are there. That's why you have to round off up to the 2 decimal places. 3.47 is the right answer, because 1 and 3 are both are less than the 5, that's why they can omit it. Finally what you get? 3.47 is the here answer. Yes, in this way we can use the significant figures rules in case of addition. For addition, subtraction, we have to use the same rule. Look here, some examples are given. The first one is 12.63 minus 10.2. Among these numbers, this one has 2 decimal places and it has only 1 decimal places. That's why n value is what? S1. Which is having least decimal places, that should be taken as n. Now we have to do the subtraction here. 3, it is like this here, 3 and 4, and it is now 12 minus 10, 2. 2.43, this is the answer. And it has how many decimal places? 2. 1, 2. Now it is rounded to the only 1 decimal place. That's why 3 is going to be dropped, and that is 3 is less than the 5. That's why simply we can leave it. So now answer is what? 2.4. It has only 1 decimal place. That's why here what you have to write? 2.4. In the same manner, we have another example. One is 62.831 and next one is 24.5492. So we have to subtract these two. So once you can check the how many decimal places in each number, you have to check it. So here 1 2 3, in the first number how many decimal places? 3, and in the second number how many are there? 1 2 3 4. Clear? So here what is the value? N value? N is equals to 3. That's why here the result also going to be rounded up to the 3 decimal places. 0 minus 2 and 10 minus 2 means what? 8. Here 0 9, that means what? Again 10 minus 9 1. 12 minus 4 8, and 7 minus 5 2, and again 12 minus 4 8, 5 minus 2 s. Now 38.2818. Again Here how many decimal places they are here? 1, 2, 3, 4 are there, and that is going to be round off up to what? N is equals to 3. That's why here 38, 2, 8, 1, and 8 is what? Greater than 5. That's why here 1 plus 1, 2. So 38.282. So here what, right? 38.282. This is the answer as per significant figures. Now let's see how the significant figure rules can be used in case of multiplication or division. Up to now we discussed what it is in case of addition or subtraction. The final answer is going to be reported to the least decimal places among the given numbers. Clear? Now similarly here in case of multiplication or division, the given components or given numbers are there. Among all the numbers we have to select the number which has the least significant figures. That particular significant figure can be taken as n, and after doing the multiplication or division we will get some result. That result is going to be rounded off up to the least significant figures of all the given numbers. Let's see here, some examples are there. Here already I mentioned some examples along with the answers. To save our time, I already mentioned the result also here. So first see the rule. The answer to a multiplication or division is rounded up to the same number of significant figures as possessed by the least term in the calculation. The answer to a multiplication or division is rounded off to the same number of significant figures as possessed by the least term in the calculation. Here let's see here some examples are given. Example 1, 1.2 into 36.72. By multiplying this one we are getting the answer 44.064. Here 1.2 has two significant figures and 36.72 has four significant figures. So among these two, 1.2 has least significant figures, and that particular value should be taken as n is equals to 2. And now what we got the answer 44.064. That should be has how many? 1, 2, 3, 4, 5. 5 significant figures are there. So now these 5 significant figures should be rounded up to the least value of among these two numbers, that is what? And 1.2, that is n is equals to 2. So now here 1, 2, 3, 4, 5 are there. Now simply here the first 4 is going to be dropped and that should be less than the 5, that should simply omitted. Now 44.06. Now how many there? 4. Again now 6 is going to be dropped and 6 is greater than 5. Then 1 plus should be added to the 0. Then what you get? 44.1. Clear? So again what we required? Only 2 we required. That's why here this one also going to be dropped and that should be what you get here? 44. So when it is rounded off, that what you get here? 44 we will get. Now see the second example. 142.06 into 0.23. That value is answer is what? 32.6738. So here 142.06. That has how many significant figures? 1, 2, 3, 4, 5. Clear? And 0.23. That has how many? 1, 2. Clear? And final answer what is? 32.6738. After multiplying these two, what you get? This one, 32.6738. Clear? So 1, 2, 3, 4, 5, 6. How many are here? 6 significant figures are there. So in these two numbers, 0.23 has least significant figures, that should be taken as n is equals to 2. Clear? So the answer also going to be round off up to 8 is going to be dropped first. 8 is greater than 5, that's why 1 should be added to the 3. then that is what here 4, 32.674. Again that is what here children, 4 is less than 5, that is going to be drop. Simply what you have 32.67 it is there. Clear. Now how many are here? 1, 2, 3, 4 are there. Again what you have to say, 7 is greater than 5, that's why 6 is divided by 1, 32.7. Now this 7 is more than the 5, that should be here like this. So after modifying this, what we get here 33. Third example, what it is, 51.028 into 1.31. Its value is what? 66.84668. That is the answer here. So now observe here, 51.028. How many significant figures? 1, 2, 3, 4, 5. Here 1.31. It is how many there here? 3. And answer has 1, 2, 3, 4, 5, 6, 7. So how many there here? 7 significant figures. So among these two numbers, this one has least significant figures. That is what? N is equals to here 3. Now this answer is also going to be rounded off from 7 to 3 significant figures. So now here you have to write 66.84668. So this is the insignificant digit. 8 is greater than 5. Then what you have to write? 6 plus 1. Preceding number is raised by 1. Then what it is? 66.847. Clear. And again 7 is greater than 5. Again 6 is raised by 1. 66.847. Again 7 is greater than 5. Then what write? Here 66.85, because 4 is there by 1. And this 5 is the here. When we have 5 like this, before number we have to check whether it is even or odd. 8 is the even. That's why here there is no modification to it. So simply here, now this value is what? 66.8. Let's see now some examples in case of division. I already told you, in case of multiplication and division we have to follow the same rules. So examples are given here now. 1101 by 10.02, that is equals to, we are writing the values 107.94117647. that is the answer here. So now for how many significant figures the answer is going to be rounded off? Let's see here now. 1101, it has 4 significant figures, it's very clear, and 10.2 is has 3 significant figures. So among these two, this is the least one, that's why this value is taken as n. Now this answer also going to be rounded off to up to 3 significant figures. Clear now. So first, before going to that, you have to identify the how many significant figures in the result. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many here? 11. Let's check once again. 1, 2, 3, 6, 9, 11. Okay. So let's hear 107 9.411767. Now 7 is going to be dropped, and that should be here more than 5. That's why here 4 plus 1 we have to do 107.9411765. And now here the last digit is equals to 5, then it is having preceding number is even, that's why there is no modification to 6. We can write 107.941176. Clear. And this 6 is greater than 5, that's why here 7 is divided by 1. Then what is here? 107.9411, it is 8. So now 8 is greater than 5, that's why 1 plus 1, then 107.9412. Clear. This 2 is less than 5, that's why it is going to be dropped. 107.941. Clear. Today how many here? 1, 2, 3, 4, 5, 6. Clear. So 107.941. These two are less than the 5, they are going to drop 107.9. and this 9 is greater than 5, that's why we can add 108. So here the answer is going to be rounded off like this, 3 significant figures, 108. 0.90 divided by 4.26, it's 0. So 0.2112676, that is the answer here. 0.90 has 2 significant figures and 4.26 has 3 significant figures. So n value is now 2. And this is how many here? 1, 2, 3, 4, 5, 6, 7 there. Again, that is rounded up to the 2 significant figures. Let's see how it is possible. 0.2112676. 6 is greater than 5. That's why 7 should be raised by 1. 0.211268. Again, 8 is greater than 5. Then 6 is raised by 1. 0.21127. Again 7 is greater than 5. Then 2 is raised by 1. So 0.2113. Now 3 is less than 5, that should be omitted. Then what you get here? 0.211. So this is has 3 significant digits. So now its answer is what? 0.211. So dear students, in this way we can use these significant figures in different arithmetic operations such as addition, subtraction, multiplication and division. In case of addition and subtraction, we can count only decimal places, but in case of multiplication and division, we have to check the least significant figures among the given numbers. So I hope you understand. If you can understand this one, like, share, comment the video. And dear students, if you want to get the more videos from my channel, then please support my channel and share my channel to your friends also. Okay, thank you for watching.